important to regulate blood pressure, as we mentioned, because regulating blood pressure will give you a sort of a constant range or a constant filtration rate that will allow for an adequate regulation of extracellular fluid. You can regulate things, and I think we've mentioned this before, right? There are two different ways to regulate any physiological function. You can do it locally, and you can do it systemically. So if we regulate a function locally, what we're saying is that we're not affecting the entire system. We're affecting only a little portion of it. So with regard to the urinary system here, if I say I'm regulating blood pressure locally, I'm affecting blood pressure of only some glomerulus, right, and not all of them. But if I say I'm doing it systemically, I'm regulating all of them. And it's important to keep the distinction different because they're almost counterintuitive the way they would work. And this will become clear here in a minute after. We've already talked a little bit about blood pressure regulation. Systemically, the mechanisms for regulating things systemically are your nervous system, right? So you can use your sympathetic and parasympathetic branch of your nervous system to regulate things systemically. But as soon as my brain starts some kind of sympathetic response, it's pretty much everywhere in my body. And that's because part of a sympathetic response is a release of epinephrine, and epinephrine is a hormone, and hormones are also systemic because hormones go where? In the blood and everywhere in the body. So the endocrine system and the nervous system will cause you to regulate things on a global systemic level. All right, now, local is through chemical signals that are released locally, like paracrines or autocrines, right? Because remember, those two signals are carried just by extracellular fluid around the cells that secrete them. So that's going to just be local. So if you have a cell right here secreting something that's affecting a glomerulus, it's only going to affect the ones that are right around it. And the other local, I don't know if this will make sense or not, but the other local way that things are regulated is through intrinsic properties. Now, remember, intrinsic, this is all extrinsic, right? These are things that are being secreted that will affect something else. This is due to a structure of something in and of itself. Right? So the structure of something can cause a regulation. So remember, for example, preload, right? Just the structure of cardiac muscle tissue means if you stretch it, it will recoil. Okay? We didn't do anything to it. That's just a function of its structure. So let's think about this over here now. There are two different ways that to regulate, if we were regulating blood pressure here, which is really the only thing we can regulate, we don't want to affect the osmotic concentration of blood because that's everywhere in the body we're going to be messing with things. We don't want to affect, well, we can't affect the capsule. I can't change the structure of the capsule to help regulate the filtration rate. So the only thing that I can really regulate is the blood pressure. And the body can regulate the blood pressure very well, right? Remember this. Remember that? Blood pressure was cardiac output times resistance. But this is what? Is this local or systemic? This is systemic. So everything that we talked about before, and I think you guys wrote about on your take-home exams or whatever, about blood pressures and cardiac outputs, preloads and whatever, all of that is systemic. So all of that applies here as well. If for some reason glomerular filtration rates were really low across the whole body, so my urinary output was really, really low across my whole body, it would do this. It would increase your cardiac output, it would increase your resistance, your heart rate would go up, all of those things to try to bring that blood pressure back up so that the glomerular filtration rate would hit. But sometimes it's just a single or several or a few nephrons that are being affected. And you wouldn't want to, if not every nephron was being affected, you wouldn't want to have a systemic response, you would want to have a local response. So the question now is that, okay, we know we can affect blood pressure systemically, that's pretty easy, and we'll see even a bigger way we can do it in a few minutes. How would you affect blood pressure here locally? What could we do that would affect this locally? There are two properties that will occur here. One of them is intrinsic, and it's called myogenic autoregulation. I'll comment on that in a minute. So that's intrinsic. That means what? We're not doing anything to it. It's just because myo means what?
Muscle.
Muscle. Genesis. Anybody know what Genesis means? It's the first
Origin.
book in the Bible. Origin, right. So the origin of this is the muscle itself, right? So this is created by the muscle. Okay? So that's why it is auto, is because it's the property of the muscle itself. So let me tell you about this one right away. This is pretty easy. What do muscles do when they stretch? What do they want to do? Recoil. They want to come back, right? If I stretch a muscle, it's going to want to recoil because they're elastic. All right. If the pressure in here, just this one, is really high, that means this afferent arteriole, is it stretched or relaxed? It's got a high pressure coming in, it's stretched. Right? What does it want to do as soon as it's stretched? It wants to, well, not relax, but it wants to recoil. Right? So it's got high blood pressure right there, it's being stretched, so what does it want to do? It wants to recoil. And it will. And as soon as it recoils, what happens to the amount of blood coming into the glomerulus? Less blood in the glomerulus. And as soon as there's less blood in the glomerulus, what happens to the pressure? Goes down.
Goes down.
Right? Less blood, less pressure, less filtration. We just regulated that, right? High filtration rate due to high pressure, stretched here, recoil, less blood in, less pressure, lower the glomerular filtration rate. So that's autoregulation. That's pretty straightforward. So here, this vasoconstriction, if you will, right here that was occurring, actually was causing a drop in the blood pressure to this one glomerulus. Okay. Also, kind of erased all of that, but that's one.